Hello Professor, my name is Saimini Saridi and this is my submission for CS610, Assignment 1. Let's start with the first algorithm, insertion sort. So to sort an array of size n in ascending order, insertion sort performs two operations. It iterates through the array from the first index to the nth position and compares the key element, which is the current element here, to its predecessor. If the key element is smaller than its predecessor, it compares it to the elements before the predecessor. And it moves the greater elements one position up to make space for the swapped element, the smaller element here. So it uses two loops to go through these operations, and hence the runtime efficiency is big O of n squared, and it's a P problem. A problem is assigned to be P class if there exists at least one algorithm to solve that problem such that it can be solved in polynomial time. Moving on to the next algorithm problem, traveling salesman problem. It goes as, given a set of cities and a distance between every pair of cities, the problem is to find the shortest possible route that visits every city exactly once and returns to the starting point. Here, an obvious solution is brute force solution to check all the possibilities. But this method would take a factorial time to go through all the permutations of the city. Luckily, there is a special way to break the problem into sub-problems using dynamic programming, but still it can take exponential time to solve it. So there has been debates if whether traveling salesman problem is an NP complete or an NP hard problem. I would say it's an NP hard problem as it is difficult to solve or find a solution. Even though traveling salesman problem can be reduced to a Hamiltonian circuit problem in polynomial time, but we do not have a polynomial time verifier for a claimed Hamiltonian circuit, whether it is the shortest or not, because you simply have to enumerate all possibilities, which consumes the factorial order of space and time. And hence, I would say this is an NP hard problem. Going on to the next problem, finding the sum of all arrays in a 3D array. So 3D array can be visualized as a problem. Let's consider a scenario of apartments in a building. Suppose there are 10 floors in the apartment and each floor has 5 flats. Each flat has 3 rooms. To handle such kind of data in programming, 3D arrays are used. As is multidimensional, it would take one loop to iterate through each element in one dimension. So hence it will take 3 loops to iterate through all the 3 dimensions. So hence the runtime efficiency would be big O of n cubed. It is a P problem as it can be solved in polynomial time by a non-deterministic Turing machine. Going on to the next algorithm, radix sort. So radix sort utilizes counting sort to sort the elements in ascending order. Let's take this example. This is an input array and has to be solved in ascending order. So counting sort would take the key element. Here the key element is the last digit of each element and compares them and swaps the elements accordingly. So the 170 being the lowest number, it will take 170 as the first digit. It is in place algorithm, so it would take 170 as it comes first in the array and not 90. Going on to the second iteration, it will take the second last digit, which is 7 over here, and 9, 0, 2. As 2 does not have any more digits in front, it would assume it's 0 in the front, and it would swap elements accordingly to the second last digit. And in third iteration, the key element would be the first digit and swap the elements accordingly. By the final iteration, we have the sorted array in ascending order. So radix sort takes big O of L into n plus k time, where n is the number of items to sort, L is the number of digits in each item, and k is the number of values each digit can have. So this is a P-class problem as it can be solved in polynomial time. going on to the last problem, the brute force password cracker. So the problem is to crack the password, which can take in numbers, uppercase and lowercase letters. There are 26 uppercase letters and 26 lowercase letters and 10 numbers. So each character in the password would take 62 combinations. And to approach anything, this is an interesting picture I found online. Here it's the time takes for a hacker to find the brute force of your passwords. Let's say if for smaller characters, for numbers, uppercase and lower characters, it takes as much as 3 days or lesser. Like for 8 till 8 characters, it only takes 1 hour for a hacker to crack a password. But as the characters keep increasing, it takes, if you just see at the 14 years, it takes, for 14 characters, it takes 9 million years to brute force a particular password by a hacker. So it takes the runtime efficiency of big O of 62 to the power n, because it has to try every possible combination in order to crack the password. It is an NP complete problem, as it goes as a non-deterministic Turing machine can solve it in polynomial time. A deterministic Turing machine can solve it in exponential time and verify its solutions in polynomial time. Thank you. This is my submission for the assignment 1, and the pictures have been taken from online, so I lay no claim over it. Thank you.